Welcome back to N's NotebookLM. So, why are some people smarter than others? It's this question that has fascinated us forever, right? It sparks endless debates, but today we're going to skip the opinions. We're diving straight into the neuroscience to see what the brain itself can tell us about intelligence.
Yeah, let's just start right there with that big, fundamental question. What is it, biologically, that separates just everyday thinking from some truly extraordinary mental ability? Well, the answer is way more complex and, honestly, more fascinating than you might think.
I mean, just think about this guy, Daniel Tammet. He studied a printout of pi for a month, right? And then he recited it from memory perfectly for over 5 hours. That's 22,514 digits. So is that what we mean by smart, this incredible, almost superhuman memory? Or is intelligence something else? Something, deeper, more fundamental?
Well, to even begin to answer that, scientists had to get really specific. I mean, think about it. Before you can find intelligence in the brain, you have to define it, and this is the crucial part, you have to be able to measure it.
So to get to the bottom of this, researchers found something really interesting called the positive manifold. It's a fancy term, but all it means is that scores on all these different kinds of mental tests, verbal, spatial, memory, you name it, they're all positively correlated. People who are good at one tend to be good at the others. And that suggests they all share some common element which psychologists named the general factor of intelligence, or just G. You can think of G as like the CEO of your mental abilities. It's sitting at the top of this pyramid and it's influencing everything below it.
Now, I know what you might be thinking. There's this common myth that IQ tests, which are one of the best ways we have to kind of estimate G, are biased or just basically meaningless. But the scientific reality, it's pretty startling. A single IQ score taken in childhood has been shown to predict not just your grades or job success, but even how long you're likely to live. Wow. Okay, so if intelligence is a real, measurable thing with these huge consequences, the next logical question has to be, where does it come from? And that, my friends, leads us straight to our genes.
And this is where things get really interesting, where our usual assumptions kind of get turned upside down. You'd think, right, that the influence of your genes would fade as you have more and more life experiences. But studies show the exact opposite is true. The heritability of intelligence, that's the amount of difference between people that can be explained by their genes, it actually increases as we get older. It goes from around 40% in childhood to as high as 85% in adulthood. That's wild.
And this points to a really key finding from all those twin studies. The things we usually think shape intelligence, like being raised in the same house, with the same parents, the same books on the shelf, scientists call that the shared environment. Well, its influence drops off a cliff as we age. It gets close to zero by the time we're adults. It seems like as we grow up, we use our genetic tendencies to pick the environments that suit us, which just amplifies that initial genetic signal.
So, if our genes are laying down the blueprint, how does that actually translate to the physical brain? What does a more intelligent brain actually look like when it's in action?
Well, one of the leading theories is something called the brain efficiency hypothesis. And the idea is it's not about using more brain power, it's about using it more wisely. There was this famous study where people learned to play Tetris. When they first started, you could see on the brain scans their brains were lit up all over the place, working really hard. But after weeks of practice, even as they got way better and the game got faster, their brains actually showed less activity. It's like their brains had learned which neural pathways were unnecessary and pruned them away, becoming way more efficient. Smarter brains basically get better mental mileage.
And what's really cool is that researchers have now actually mapped the specific networks that seem to be the most important. After looking at dozens and dozens of brain imaging studies, scientists came up with the parieto-frontal integration theory, or PFIT for short. It basically identifies a superhighway of brain regions that are consistently linked to how well people do on intelligence tests.
So let's actually trace this flow of information. Say you're solving a problem. First, information comes into the sensory areas, way at the back of your brain. Then it gets integrated and analyzed in your parietal and temporal regions. From there, it zips up to the frontal lobes for what's called hypothesis testing. That's basically you deciding what to do next. And finally, a command gets sent out to the motor cortex to act. Intelligence really seems to be about how well and how quickly information travels through this very specific network.
Okay, so if we know which brain networks are involved in intelligence, it raises the million-dollar question, right? Can we train them? Can we actually make ourselves smarter?
Well, back in 1993, a study published in the super prestigious journal Nature seemed to scream yes. It made this explosive claim.
Just listening to 10 minutes of a Mozart sonata could temporarily boost your spatial IQ score by a whopping 8 points. And just like that, the Mozart effect was born.
But you know what they say, an extraordinary claim requires extraordinary evidence. So, did this one actually hold up under scientific scrutiny?
The short answer? Nope, not at all. The original study was tiny and had some serious methodological flaws. But more importantly, hundreds of attempts to replicate it just failed. It turns out the effect didn't actually boost general intelligence, that G factor we talked about, and any temporary lift was probably just due to mood or arousal, and it faded super quickly. And, similar claims for all those brain training games have also pretty much failed to show that they increase your underlying intelligence rather than just making you better at the game itself.
So, if we can't just listen to music or play some games to boost our IQ, where does the future of this research even lie? Well, the answer is coming from these massive new projects that are mapping the human brain in just unbelievable detail.
Yeah, a landmark study from the Human Connectome Project made this absolutely stunning discovery. It turns out the way all the different areas in your brain communicate with each other creates a unique pattern of connectivity. It's a pattern so stable and so specific to you that it could be used to identify you from a group of people based on your brain scan alone. They actually called it a brain fingerprint. But here's the truly revolutionary part. This unique brain signature isn't just some piece of neurological trivia. The researchers found that the specific pattern of your brain fingerprint is strongly correlated with and can be used to predict your fluid intelligence, your ability to reason and solve brand new problems. And that leaves us with a really profound question for the future. We're moving so fast from understanding intelligence as this abstract idea to being able to literally read it from the brain's wiring. As this technology develops, we're going to have to decide as a society what that means. So let me leave you with this. If your brain is your fingerprint, who gets to read it? If this topic has captured your interest and you'd like to dive deeper, the book is called The Neuroscience of Intelligence by Richard Hare.